All right, hello everyone. I really appreciate you guys being here today. I'm Jason Corrig, Account Director here with Simbi Robotics, and I really want to welcome everybody, what I believe is from around the world, to our webinar here on RFID and robotics. I'm excited to host this today because we're going to be hearing from Jonathan Aiken, which is Avery Dennison's Intelligent Labels Division Director for RFID. And then following him, we're going to have Simbi's very own Brad Begolia, our CEO and co-founder, who's going to tell us all about our robot Tally.
Like Jason mentioned, my role is Director of RFID Partnerships, and so I'm on the strategy team. So let me just tell you a little bit about RFID. So it stands for Radio Frequency Identification, but what it is RFID is the ability to transfer data to and from tags wirelessly, and it's fast, reliable, and now in today's age, contactless. So RFID signals can go beyond line of sight. So you can go through a stack of clothing. So if you have a whole bunch of jeans on a shelf, you can count all the jeans on a shelf very, very rapidly. So it makes it ideal technology for counting inventory very, very quickly. You can see RFID is embedded into all of these tags here on the screen. So how does it work? It looks pretty simple, right? And it is if you have the right partner. You basically take a standard label, which you have here on the left, and you put an RFID inlay behind it. And now you have an RFID-enabled label. And the way that we do this is we take this blank label with nothing printed on it, we convert it to add an RFID label inside it, and then we run this through an Avery Dennison RFID printer, and we print and encode all this metadata onto the outside of the label. The metadata, such as price, barcode, etc., gets printed on the outside, and then the only thing that gets put on the inside on the chip is actually what we call an EPC, which is an electronic product code, which is basically the SKU that's represented on the barcode, along with the serial number to make that unique to that particular tag. And that uniqueness is really what brings the power to RFID. Note that the chip does not contain any metadata. I get that question a lot. What's actually stored on the chip? It's actually pretty simple. The chip doesn't have a lot of memory inside it, and that's to keep the costs down. So the EPC standard for storing data on an RFID chip says that you just store the serial number. So there are some that can store a little bit more, but basically that's what you store. The EPC is then decoded back to get to the barcode to then do and that acts as a primary key in a database to then look up information. So in a point of sale, or in the case of Tally, the EPC is sent to Tally, and then Tally knows what to do with the EPC. Okay, so how does it work? So Tally roams around the store, sends off a radio signal that prompts these RFID tags. The tags then wake up, and they respond back to Tally and say, hey, I'm this EPC, or I'm this EPC. So even if the tags look the same, they're actually different. And you can see on the right, they're just different serial numbers. So these tags are passive. So this is passive UHF RFID. Passive means that they have no battery in them, which you can see kind of from the diagram. But it means that they can lay asleep for days, weeks, months, or even years. And then once they're excited by this RFID signal, they wake up. So the tags basically absorb energy from Tally, and that is actually what excites the chip, and then the chip responds back and says, hey, I'm this EPC, and then it sends it back through the antenna back to Tally, who's listening for the response. And this happens in just fractions of a second, so you can read hundreds of tags in just a second or less. I wanted to tell you a little bit about what we have to offer in addition to RFID is we actually have a test lab that's available in Miamisburg, Ohio. In this lab, we actually test a variety of different products, including Tally, but we do scientific tests where we actually put in RFID tags on your product, and we'll put it into an anechoic chamber, which is that chamber in the middle. It looks like a recording studio, but basically it dampens the sound in the radio waves, and we test to make sure that the tags are responding correctly. We also have a mock distribution center where we have other products like RFID tunnels, and we have a mock store where we can actually set a robot loose and traverse your products and see how well it picks up the RFID tags. We can test a variety of different sizes of tags, as well as different types and where they're attached onto the products. We also have RFIDs or custom tags that work on liquids, on metals, things like meat if you're a grocer. And we also have a microwave safe tag as well. So if you take an RFID tag and you stick it in the microwave, it will actually catch on fire in about 10 seconds. So, but we have ones that are specially designed for frozen foods, meats, things like that might actually go into a microwave, and they can last in the microwave for 5 minutes or more. So if you really want to test RFID or you want to come to a visit in the RFID lab, hit me up on LinkedIn, and we're happy to arrange a tour in Miamisburg, Ohio. So now hopefully you have a brief overview of who Avery Dennison is, what RFID can do for you for inventory accuracy and omnichannel, and how we can help you succeed with your RFID program.
Symbi as a company was really founded with the core mission of helping retailers better understand what was actually happening in their physical stores, especially in regards to inventory and store operations. We're specifically help retailers know what products are stocked, are they in the right place, do they have the right price, and we do this through our autonomous mobile robot Tally, coupled with sensing technologies like RFID, in addition, coupled with machine learning and a suite of cloud services. As a company, we were founded just over 5 years ago, and our core technical brain trust actually came out of a world-renowned robotics think tank called Willow Garage. Willow Garage had invented what is known as the robot operating system, but it's really the de facto standard in building robotic applications, kind of like what Android or iOS is to mobile applications. We're a venture-backed company headquartered at the tip of Silicon Valley near San Francisco. We work with more than a dozen global retailers today. We have robots in more than 6 countries, and our global fleet of robots have traveled more than 50,000 miles in physical stores, performing tasks like inventory auditing. As a company, when we first started, we actually announced a grocery auditing robot using computer vision, and within the grocery market, we take tens of thousands of high-quality 2D and 3D images of stores to analyze whether product is stocked, is it in the right place, does it have the right price. Through this process, we got a lot of interest from other higher-end soft good apparel style retailers because they were going through many of the same inventory challenges that grocers do. As such, we began thinking about bringing a RFID style robotic product to market. Some of those challenges that Jonathan talked to were just, really the challenges around manually auditing inventory, the frequency and the reliability of that data, the amount of time you're really spending with labor conducting this task. Oftentimes you may need to leverage third-party services or actually conduct these audits overnight. Are retailers really maximizing the true benefits of RFID and better inventory data? And how does this type of information really integrate to retailers' existing, IT systems and business processes? So as we progress today, we'll talk more about these pieces. So with the interest we had in the original Tally product in 2008, we brought to market a version of Tally that really had 2 sensing modalities. One that is focused on computer vision, which, using computer vision and machine learning, we're identifying things like packaged goods on grocery store shelves. But the challenge with many soft good, apparel, sporting goods stores is computer vision does not work as effectively for these, higher value goods. And RFID is really a perfect candidate for these types of products. So we wanted to couple these 2 sensing solutions, together. And what we found is using an automated robot allows us to, very accurately in a timely manner provide inventory counts across these environments. And in addition, we're able to identify where products actually reside in store to about meter level accuracy. So some of the real challenges that retailers are dealing with today is someone orders something online, that product is somewhere in store, but people can't actually find it. In addition, for the soft good retailers, it's still valuable in understanding what this merchandising looks like. So we actually capture panoramic images of the store environment so people can evaluate the effectiveness of their planogram, their display execution or promotional execution in store, in addition to deconstructing any price tags that they may have.